We are fine, ma'am. And you?
Yeah, I'm fine.
Assalamu alaikum, ma'am.
Salam. Okay, so our last data structure was graph, right? And maybe we discussed few topics from graph, and then we started some sorting algorithms, that is merge sort, quick sort, and then we discussed tower of Hanoi. So we can again start graph. Okay, so from graph, how many topics we discussed? The first class was about some basic things about graph, right? Hello?
Yes, ma'am.
How many topics we discussed from graph? Can anyone help me with this?
Three.
I can remember the first class of graph that was about some terminologies. And then, did I discuss the graphical, matrix representation of graph?
No, ma'am. It was left.
I didn't discuss adjacent matrix. What about path matrix? No, maybe.
Maybe there are no metrics you have done yet.
But I think I discussed about adjacency matrix, that how we can represent the graph using adjacency matrix. Okay, no problem. I'll discuss those things again. And then some traversal technique, that is BFS and DFS. That was the last topic from graph. So we can start from the beginning. So what is graph? Graph is data structure. What kind of data structure it is? Nonlinear data structure. So how we can define this data structure graph, or when some value, some nodes are given, how we can represent, how we can create the graph. At first we need to know what is graph. It consists of some nodes and age, right? Look at this. We can represent the graph using, if G is the graph, then G should be made of some vertices and some edges. So we need a set of vertices and a set of edge. So look at this graph. If this is a graph, then how many vertices it has? 5 vertices, A, B, C, D, E. So this is the set of vertices B, and it includes how many vertices? 5 vertices. And what is edge? Edge is a connecting line. Suppose some nodes are given, so how we can connect them? By using some connecting lines. So these are the edges. So how many edges are here? 5 edges, AB, AC, CD, BD, and DE. So in a graph, we have a set of vertices and a set of edges. So this is a graph. So what is vertex? Vertex are actually the node in this graph. A, B, E, F, C, G, D. These are the vertex. Okay. And what are the edge? Edge are the connecting line, or these are the connecting lines of 22 nodes, right? And we talked about some terms like path, cycles, and loop also, isn't it? So in this graph, how many vertices are given? 7 vertices, A, B, E, F, D, and G. There are 6 vertices. And how many edges are here? The edges, that is the connecting line between 2 nodes. So there are 6 edges. Isn't it?
Yes, ma'am.
Okay. So now how we can find out this adjacency of the nodes or the vertices? What is adjacency? Suppose if we want to find out which nodes are the adjacent node of A, then we need to find out with how many vertices this node A is connected, right? Or how many edges contains that node A. So here A is connected with 3 vertices, B, E, and F. So these 3 nodes are adjacent node of A, right? And what about D? D is connected with only one node, that is C. So C is the neighboring node or adjacent node of D. And for G, the adjacent node is F, right? So what is path? Suppose we want to travel from this node A to D. From A to D. So now look at this graph. in how many ways we can travel from this node A to D? There is only one way, and the way is A, B, C, D. So this is the path sequence of the node A and D. That means the way for traversing or the traveling from this node A to D is only one, and that path sequence is A, B, C, D. And what is the length of that path? The length is 3. Okay, so the length means between these nodes, how many edges we can find? Only 3 edges. One is between A and B, another is from
Allah. Guys, can you hear, ma'am?
No, now, not now. Ma'am got disconnected.
hello.
Yes, ma'am, we can hear you.
Yes, ma'am. Now we can hear.
Hello.
Yes, ma'am. We can hear.
So what is path sequence? So what is the path sequence of A and G? The path sequence is AF and G, right? So how we can define the path sequence? Suppose this is our source node A and this is our destination node. So now we have to find out how we can travel from that node A to G. So there is only one way and once, right? And how we can find out the length of that path by counting the number of edges. So here between A and G there is only 2 edge. One is from A to F and another is from F to G. So the path length is 2. Clear what is path length? And there are some other path sequences also. Can you remember we discussed about loops as well as about the cycle? Okay, so in this graph, is there any cycle?
No, ma'am.
No. Why not? What is the definition of cycle?
From where
In
it's
cycle-
begin, it's end there.
Yes, very good. That means the starting node and the end node are same, but between that starting node and end node, there should be some other nodes or vertices. Suppose here, if we draw a line from D to E, at that time, if we want to travel from A to, suppose we want to find out a cycle, at that time the cycle will be A, B, C, D, E, A. So a cycle is a path sequence where the starting node and the end node are same, but between that starting node and end node, there will be some other nodes such as B, C, D, E. That is cycle. What is loop? In a loop or closed path, the starting node and the end node will be same, but there will not be any other nodes between them. That is loop. And there are some types of graph. Remember, we discussed about simple graph, connected graph, complete graph, then weighted graph, multi-graph, and tree graph. There are 6 types of graph. So here, the first one is multi-graph. There are 2 characteristics of multi-graph. One is multiple edges and another is loop. What is multiple edges? Look at this. Between these 2 nodes, 0 and 1, there are 2 edges. So when 2 nodes are having more than 1 edge, this is called multiple edge. And that graph containing more than 1 edge between any 2 nodes is called multi-graph. So why this graph is called multi-graph? Because between these 2 nodes, there are 2 edges. And this is not undirected graph, so we don't know which one is the starting point and which one is the end point. We can just assume that 0 can be starting node or 1 can be destination node, or we can use 1 as the starting node and 0 as the end node. And another characteristic of multi-graph is loop. What is loop? An edge where the starting point and the end point are same. So this is a loop. Here the starting point is 4 as well as the end point is 4. So a multi-graph can have multiple edges, that is similar, more than 1 edge between any 2 nodes. So this is multi-graph. Now the next one is tree graph. What is the main
Ma'am, your voice is
characteristic of tree
breakdown, ma'am.
graph? The main
Several
characteristic of tree graph is, okay, let me just fix it. Okay, so what is the main characteristic of tree graph? There are 2 characteristics. One is, in this graph we cannot find, or all the path will be unique simple path. And another is, we cannot find any multiple edges or loops in a tree graph. So the first one is unique simple path. So what is simple path? Simple paths are simply a path sequence where the starting node and the end node are not same. And unique path is, that means between any 2 nodes we cannot find more than 1 path sequence. So in a tree graph, all the path sequences are unique simple path. Just think about this one. Suppose between 0 and 2 we want to find out a simple path. So how many paths are here? Only 1 path. 0, 4, 1, 2. This is a unique simple path between 0 and 2. So we can only visit that node 2 from 0 in how many ways? In only 1 way. So that's why this graph is called tree graph. And another important thing about tree graph is, if the number of nodes is n, then how many edges we can add? Only n minus 1 edge. So in this tree graph, the number of nodes are 5. That's why we have how many edges? Only 4 edges. So a tree graph is a graph where the number of edges depends on the number of vertices. If the number of vertices is n, then edge will be n minus 1. And in this tree graph, all the paths are unique simple paths, and there are not any, we cannot add any loops here, or multiple edges are not allowed in tree graph. Now the next one is weighted graph. What is weighted graph? If we add some value to these edges, then we can call it weighted graph. Okay, and in weighted graph, we can find out which one is the shortest path. Suppose if it is a simple or it is a connected graph, then we can have more than 1 way for traveling from one point to another point. Okay, suppose we want to travel from 0 to 3. So in how many ways we can reach to that point from 0 to 3? There are 4 ways. One is 0, 4, 3. Another is 0, 1, 3, and then 0, 1, 4, 3, or then 0, 1, 2, 3. Okay, so which one will choose? Obviously the one with the shortest path. So if we take the first path, that is 0, 4, 3, then we can count the weights. Between the weight of this edge is 3, and for this edge the weight is 3. So 3 plus 3 equals to 6. If I choose another path, that is 0, 1, 4, 3, then now we can count the width. 4 plus 4, that is 8. 8 plus 3, 11. So which one will take? Obviously the shortest path. That is the previous one. 0, 3, 0, 4, 3. So weighted graph is a graph where all the edges have some weights, some value. That is called weighted graph. Okay, there are some other graphs, that is simple, connected and complete graph. So what is simple graph? Suppose there are some nodes 0, 1, 2, 3. So now how we can create a simple path here between these 4 nodes? Simple path, that is each node will be connected with at least one node. Okay, so here 0 is connected with 1, and then 2 will be connected with suppose 0, and 3 is connected with 2. So what kind of graph it is? It is a simple graph. And when we can call it connected graph? We can call this connected graph when we can add edges between any 2 nodes. That is called connected graph. So here we can add a node edge between 0 and 3, between 1 and 2. So this is connected graph. And another type of graph is complete graph. What is complete graph? In a complete graph, one node will be connected with all the other nodes. So here 0 is connected with 1, it's connected with 2, and it's also connected with 3. In this way, each node is connected with the other 3 nodes. So it is called complete graph. And all these graphs are undirected. Why it is undirected? Because the directions are not given. So here the edges can be used as an edge from 0 to 1 or from 1 to 0. So all these graphs are undirected graph. So what is directed graph? When the directions are given, that is called directed graph. And the directed graph can have multiple edges and it can have loops also. So this graph is a directed graph. Okay, so suppose the given graph is undirected, this one. So how we can find out the degree of the nodes? In this graph, there are 5 nodes. So how we can calculate the degree? Hello, what is the degree of a node?
Number of edge levels.
Number of levels.
Yes, ma'am.
Do we know how to find out the adjacent nodes? Yes, right? We know how to find out the adjacent nodes. So this is an undirected graph. And now, suppose we want to find out what is the degree of 0. Then how we can find? Yes, the degree of 0 is 2. So we just have to find out with how many other nodes this node 0 is connected, or how many edges contains that node 0. So here there are 2 edges starting from 0 because it's undirected graph, or 2 edges contains that node 0, or 2 nodes are connected with 0. That's why its degree is 0. 0 is connected with 4 and it's also connected with 1. So its degree is 2. What about 3? 3 is connected with how many? Very good. 3. It's connected with 4, 1 and 2. That's why its degree is 3. So this is for the undirected graph. What about directed graph? Suppose this one. So now in this directed graph, the directions are given. So now we know which one is the starting. For any edge, we can find out which one is the starting point and which one is the end node, right? And each directed graph can have, or each node in this directed graph can have 2 types of degree. One is in degree and another is out degree. Okay, so what is out degree? Out degree, that means we have to find out for how many edges that node is starting node. That is out degree. So what is the out degree of 0? The out degree is
0.
Because all the edges have started from the other nodes and end at 0. That's why it's out degree 0. Okay, what about the incoming degree?
2.
The incoming degree is 2 because here there are 2 edges where the starting nodes are 4 and 1, but the end point is 0. That's why its incoming degree is 2. What about 3? What is the in degree and out degree of 3?
In degree is 2, out degree is 0.
Very good. In degree is 2 because there are 2 edges, and for these 2 edges, 3 is the receiving end, 3 is the end point. That's why it's in decrease 2. Okay, but why it's out decrease 0? Because there are
No
no
path is going
ages
out.
where, yes, 3 is the starting point. And for 2, the in decrease 1 as well as the out decrease 1. Okay. Okay, now the next topic is how the graph can be represented. There are two ways for representing the graph. One is using matrix, another is using linked list. So the first one is adjacency matrix. So here, look at this graph. How many nodes are here?
5.
5.
5 nodes. And matrix, that means the two-dimensional array. Okay, so the matrix will have some rows as well as some columns. You can say that matrix is n into m array, where n is the number of row and m is the number of column. But for graph, both the value of row and column will be same. It's equal to the number of nodes of that graph. So we can say that the adjacency matrix is actually n into n matrix, where n is the number of nodes and where the number of row and column are equal to the number of nodes. So here n equals to 5. So this matrix is a 5:5 matrix. So now how we can create this adjacency matrix? In this matrix, how many cells we can have? 25 cells. N into n, 5 into 5 equals to 25. So we can put 25 values. But how many types of values we can add here? Only 2. That is 0 or 1. So how we are creating this adjacency matrix? We just have to find out for these nodes how many adjacent nodes are here, or is there any adjacent node of this given node 0, 1, 2, 3, 4. If the answer is yes, then the value will be 1, otherwise the value will be 0. Isn't it? How we can create this adjacency matrix? Suppose this is our graph with 4 vertices, 1, 2, 3 and 4. And this is the directed graph. So one is from 2 to 1, another is from 1 to 4, then 1 to 4 to 3, 2 to 3, 2 to 4, and then 3 to 1. Okay, so this is a directed graph. Okay. So now from this graph, can we create the adjacency list? How
Yes,
many
madam.
nodes are here? 4 nodes. 1, 2, 3, 4. Adjacency matrix, that means we have to find out for each of these nodes, is there any adjacent nodes here? We have to find it out. So the first one is 1. Okay, so how we can find out the adjacency node? If 1 is the starting node for any edges, then suppose, look at this. Suppose this edge, the direction is from 1 to 2. At that time, we can say that this 2 is the adjacent node of 1. Because one edges has started from 1 and reaches to that node 2. So 2 is the neighboring node of 1. But here the direction is from 2 to 1. That means 2 is not the adjacent node of 1. So which node is the adjacent node of 1?
4.
Only 4. There is only one edge started from 1. So 4 is the adjacent node of 1. Now the next node is 2. For 2, there are how many adjacent vertices? 3 adjacent vertices. 1, 4, and 3. So 1, 3, and 4. These are the adjacent node of 2. And then the next node is 3. Only 1 is the adjacent node of 3. What about 4?
3.
4 has how many?
3.
Only 1. That is 3. Okay, so this is our adjacency list. Now how to represent this graph as adjacency matrix? It's n into n matrix. That is, the number of row will be 4 and number of column is 4. Okay, so here these are the value of the row and these are the value of the column. So how many cells are here? 4 into 4, that is 16 cells. And how we can fill up the cell? By using the value 1 or 0. If this node 1 has any adjacent vertex, then the value will be 1, otherwise it will be 0. So for 1, only one node is adjacent node of 1, that is 4. So in this cell, we can easily put the value 0. Right? We are denoting the relationship between these nodes with each other. I mean, this one, suppose this row will be used for which node? For 1. Right? So, and here we have one value that is true or yes. Okay, that means this node 1 has only one vertex or adjacent vertex, and that is 4. Now the next one is 2. Is there any adjacency between the node 1 and 2? Yes. 1 is the adjacent node of 2. So here the value will be 1. And if we have a loop like this, then here we can put a value 1. But in this graph, we didn't add any loop. So all the diagonal value will be actually 0. So between 2 and 2, there are no adjacency, so the value will be 0. 3 is adjacent vertex of 2, so the value is 1, and here also 1. Now the next row is for 3. How many nodes are adjacent nodes of 3? Only 1. Right? So all the value will be 0. And then the next one is 4. So only 3 is the adjacent node. So this is the adjacency matrix. So in this way, we can represent the graph. Clear?
Yes, ma'am.
So from this matrix, we can only find out the adjacency between any two nodes. Right? So from this row, we can say that this 1 and 4, these two nodes are adjacent nodes. From this row, we can say that 2, 1, 2, 3, 2, 4, they are adjacent nodes. Okay, so from this matrix, we can find out the adjacency. So there is another way for finding out the path sequence. The next one is path matrix. So what is path matrix? That means you have to find out whether is there any way for traveling from one point to another point. That is path matrix. Okay, so we can get this path matrix from the adjacency matrix. The equation is Bm equals to A plus A square plus A cube plus dot dot plus A to the power m. And here m equals to number of vertices. So for the same, it's not the same graph actually. We can use the previous graph. So this is our graph and this is the path matrix. Now we want to find out the path matrix. So what is path matrix? Suppose we want to find out, is there any path, any way for traveling from 2 to 4? So look at this graph. What is the answer?
Yes, ma'am.
2 and 4 directly connected, so obviously there is a path from 2 to 4. What about this 1 to 3? Okay, 1 and 3. So is there any path sequence between 1 and 3? What is the answer? No. The answer is no. That means 0. Look at this here. The age is from 3 to 1, not from 1 to 3. Right, and another, we cannot use this one as the path sequence from 1 to 3 because it's a directed graph, and look at the direction. If the age is from 1 to 2, then 2 to 3, then we can say that yes, there is a path from 1 to 3. But here, the direction of this age from 2 to 1. So there is no path sequence from 1 to 3. So the value will be 0. So from the path matrix, you can find out about the path sequence. So how we can create the path matrix? From this adjacency matrix. And what is the equation? The equation is Bm and m equals to number of vertices. Bm equals to a plus a square plus a cube, and here the highest value will be a to the power 4 because m equals to 4. There are 4 vertices, a to the power 4. So already a is given, this is a. And how we got this adjacency matrix? I already explained it. And how we can get a square, a cube, a4? By multiplying this a with a. How we can get a square? By multiplying a with a. And we know how to multiply two matrices. At first, you have to find out about the number of columns of the first matrix and the number of rows of the second matrix. If the number of column of the first matrix and the number of row of the second matrix are equal, or same, then matrix multiplication is possible. So a square equals to a dot a. Then how you can get a cube? A cube, that is a square dot a, and a to the power 4 equals to a cube dot a. After multiplying all these matrices, then we'll get some result. And after adding all those matrices, we can get the path matrix. So now look at this slide. So this is our graph, and from this graph we got this adjacency matrix. This is the adjacency matrix. So for calculating the path matrix, we need to find out, at first we have to find out a square, a3, a4, the value of a square, a3 and a4. How we can get them? A squared, that is a dot a. We are taking the same matrices, so obviously the number of row and column will be same. And how to multiply? What is the rule for multiplying one matrix with another one? Each row will be multiplied with each column of the second matrix, isn't it?
Yes,
How you can get the value? Do you know how to just try it? This is the adjacency matrix A. So how to calculate a square, a3, a4? Please try to solve it. You all know how to multiply two matrices, right? Suppose this is your first matrix and this is the second matrix. So now each row will be multiplied. Each row of the first matrix will be multiplied with every column of the second matrix. Okay, so after this multiplication, you'll get a square, a3, a4. What is the next step? Addition of all those adjacency matrices, this one. After adding these four matrices, now we got this final matrix, that is our path matrix. 1, 0, 2, 3, these are the value of the first row, 5, 0, 6, 8, 3, 0, 3, 5, 2, 0, 3, 3. After getting the result, now the last step is now replace all the non-zero value by 1. How many non-zero values are here? 2, 3, 5, 6, 8, 3, 3, 5, 2, 3, 3. All those non-zero values will be replaced by 1. Why? Because in these matrices, we can use only two values, either 1 or 0. Right? Because these matrices will represent, is there any paths between two nodes or not? If the result is positive, true, then the value will be 1, otherwise 0. That's why we cannot use 5, 3 or any other values. After getting the final result, then replace all those non-zero value by 1. So here all these non-zero value 2, 3, 5, 6, 8 will be replaced by 1. And this is our final matrix. From this matrix, look at this row, how we got this row. Here the row value is 1 and the column values are 1, 2, 3, 4. So between 1 and 1, so why the value is 1? Did you take any loops here? Hello?
no, ma'am.
Can you hear me?
Yes, ma'am.
Yes, ma'am, we can hear you.
There is no loop. So why the value is 1? That means there are some mistakes here. Maybe put in some wrong value. So please calculate all these matrices a square, a3, a4 and then add them. Clear? So this is path matrix. And now another one is linked representation of graph, and we will skip this one. Okay, now the next topic is basic operation, that is searching in a graph, insertion of a node or deleting some nodes from the graph. And we already discussed about one operation, that is traversal. Breadth first search, that is BFS, and depth first search and DFS. So do you have any confusion in those two traversal methods, in BFS and DFS?
No, ma'am.
No confusion. Okay, so but we applied those methods. Give me a minute. Hello. We applied those technique for undirected graph, right? We applied the breadth first search or BFS technique and DFS for undirected graph. But look at this is a directed graph. Okay, so in BFS we used a queue, and in DFS we use a stack. Right? So can you solve it? Can we apply BFS technique on this graph, on this directed graph? Hello? Hello? Can you hear me?
Yes, ma'am.
Yes, ma'am.
How
Yeah,
many
yeah.
nodes here? There are 12 nodes. Okay, forget about the direction. Suppose this is a directed graph, so how we can apply the BFS technique? Just start with a node, just consider any node as a starting node or your source node, and then you have to traverse all the nodes. How? If the first node is 0, then we can traverse at first all the adjacent node of 0. What is the way of applying this BFS method? We can use a queue that is first in first out data structure. So when we will traverse that node 0, at first that node will be stored in the queue, and if we want to traverse it, delete that node from the queue and add all the adjacent node of that queue. Suppose here, if the graph is undirected, okay, look at this graph. This is directed or undirected graph.
Undirected.
Undirected.
Yes, actually, in one sense, we can consider this as undirected. Why? Because look at the direction.
Both sides.
Bidirectional. All the directions are bidirectional. So this is actually bidirectional. We can apply the same method that we used in undirected graph because the result will be the same. This 0 can be used as starting node, or any node can be used as a starting node. Okay, so for 0, the adjacent nodes are 1 and 4. So store all those nodes in the queue. Okay, then you can take which one, 1 or 4, it depends on in which order you have stored them in the queue. If you stored 1 first, then you can delete it first because queue, that is first in first out data structure. So at the time of deletion, or when you're deleting that node 1, now store all its adjacent nodes in the queue. So 2, 5, 0. These are the adjacent node of 1, but 0 is already visited or traversed, so store only 2 and 5. So now which node will be traversed now? The adjacent node of 2 and 5 or this 4? Obviously 4. This is BFS. And look at this. When you have stored these adjacent nodes of 0, 1 and 4, you just traverse 1, not 4. And before traversing the adjacent node of 1, you have to complete the previous one, that is 0. Traverse 4 first. Okay, so when you're traversing that node, at first add all its adjacent node, that is 8 and 0. But 0 is already traversed, so add only 8. So then which node will be traversed? 2 or 5. So in this way, we can apply this breadth first search or BFS. And what about DFS? I'll upload the slides so you can practice it. Okay, so the next one is DFS. And this is actually directed graph. So in DFS, we apply or we use stack, that is last in first out data structure. Right, and how we can traverse the nodes here? You can start from the beginning and you can go to the depths. Right, that means when we are traversing a node, suppose the first one is S. So after that, can we traverse? Okay, this is not actually directed graph. This is also undirected graph. This is undirected graph. Okay. So when we are traversing that node S, this is our first node, then which one will be the next node? A, B, or C? This is DFS, that is depth first search. This S is the first node, and now we are using a stack. So after traversing that node S, now we can, here in a stack, we cannot store more than one data at a time. Only one node can be stored. So this S has how many adjacent nodes? 3 adjacent nodes, A, B, and C. So we can store any one of these 3 nodes. We can take A, B, or C. So after S, we can take A. So now the stack has how many nodes? Only two nodes, S and A. Okay, so after traversing that node A, now we cannot traverse the adjacent node of S and this B and C. We can start from here, from the top, and we can go to this bottom. Okay, we can use only one direction. So now we are going through that direction from S to A, and now A has only one adjacent node, so there is only one way. So our next node will be D. Okay, now the next one will be G, and now G has two adjacent nodes, E and F. So we can take any one, E or F. So in this way, we can traverse all the nodes. And in DFS, sometimes we have to apply the backtracking. When do we apply that backtracking technique? When we can apply backtracking? We can apply
When
back
there's
or
no forward path to go, have to
Yes.
reverse only.
Yes. So in this graph, do we have to face that? Dead end?
Yes, ma'am. Yes, ma'am.
Where?
In 5, step number 5B.
Very good. Here. So from B to S, although B has an adjacent node, but that node is already visited, right? So now there is no other unvisited node of B. So now we have to backtrack from B to which node? It depends on actually the sequence of stack. So here B to E, E to G, and then now G has how many adjacent node? D and F, but D is already visited, so now we can traverse F. After that F to C, and then here again backtracking. Although we have already traversed all the node, but we have to make this stack empty. After traversing all the nodes, then we can use backtracking technique for deleting all the nodes from the stack. So this is depth first search. So in the next class, we'll discuss some other topics, that is spanning tree or minimum spanning tree, or some algorithms for solving that, minimum spanning tree problem. Okay, so now if you have any question, please tell me, because if you have confusion in these two topics, we cannot actually move forward, because these two topics are really important topic of graph. One is BFS and another is DFS. And I will suggest you please try to solve this problem for some weighted graph or some directed graph. Take some directed graph and then apply BFS or DFS. Okay?
All right, ma'am.
So any question? Any question?
No, ma'am.
Okay. 1,
Yes, ma'am.
2, 3,
Yes, ma'am.
4,